This facility has been building actuators for 40 years. We've done in excess of 10,000 applications. Linear actuator is a linear device that provides thrust. And it basically is a combination of pre-designed components that have a motor, a gearbox, and a lead screw. A hydraulic system is a fluid-powered device that is energized by the movement and pressure of fluid in multiple directions. Because it's a fluid device and it's self-contained with seals, it will inherently have contamination and leaks. So one of the major advantages of an electromechanical device today that's very popular is the green effect. There's no contamination. A hydraulic cylinder also requires power and it requires pressure to the hoses to maintain a load. An industrial linear actuator does not. Once on an actuator you fix a position within its rated load, it'll hold it indefinitely without the use of power, so there's economies there, but also for safety. You can cut the wires on an industrial linear actuator and the load will still be held. Independent of those features, industrial linear actuators are designed to work in very cold environments. Hydraulics have issues when it gets down below 30 degrees. Also, industrial linear actuators are designed to be maintenance-free for the life of the product. That isn't true with hydraulics. Hydraulics typically have to go through routine maintenance. In this facility, we will customize units specific to customers' requirements, and then we will test them. We also test new designs and new and advanced components that will integrate into our actuators.
Using this portable testing device that we have here with a load cell pin and a data acquisition system, we can determine the load, the voltage, and the current draw on the actuator in this specific application. On the screen, you can see the load changing, the voltage dropping, inrush current. We can use this setup to determine if the load that they gave us for the original specification is correct, the current draw, the voltage, and then we can optimize the actuator for them to fit this application better.
Another major advantage of linear actuators, because they are controlled by electricity as opposed to fluid power, it's much easier to put feedback on them and to integrate them with the type of microprocessors that are readily available today. So that's a real advantage, and that's helping to spur the growth. I'd like to show you a typical hydraulic setup. It'll consist of 1 or 2 hydraulic cylinders with hoses, and to support the pressure, to achieve the linear motion that's required here, you have to have fluid power, fluid pressure in both directions. In order to achieve that, you have to have a motor, a reservoir, and a pump that supplies that pressure along with hoses. To control that pressure, you typically have to have a directional control and valve controls, which all head back into a central control box. Every hydraulic cylinder will eventually leak. Everything you see here, all this equipment, can be replaced by what I have in my hand right here, making it a very simple, compact system to put together.